Now let's look at example 5 from lesson 1.7. We've got a problem where we're told that the town of Foxton lies 10 miles north of an abandoned east-west road that runs through Grimley. So this gray is our east-west abandoned road, and then Foxton is 10 miles north of that road. The point on the abandoned road that's closest to Foxton, so right here, is 40 miles from Grimley. So this point is going to be the closest point from the abandoned road to Foxton, and that's going to be 40 miles from Grimley. So now county officials are planning to build a new road connecting the two towns. The cost to restore the old road, this gray road, if we want to restore part of that, that's $100,000 per mile, whereas constructing a new road costs $200,000 per mile. So if we went directly there, it would cost us $200,000 per mile. Or even this little piece over here, is going to cost us $200,000 per mile, whereas whatever we have to restore on this old road, the abandoned road, is only going to cost us $100,000 per mile. Now we're to use this figure to help set up a model to determine how much of the abandoned road should be used if $6.8 million is budgeted for the project. So let's, first of all, we've got to figure out, we're not sure how far we're going to go along the abandoned road before we start cutting up to Foxton. So we're going to have this amount down here of X that we're not going to go along. And so now with this, we can form a right triangle over here so that we've got something to use to represent the length of our new road. We can use Pythagorean's theorem since we formed the right triangle. X squared plus 10 squared gives us this side. So this is x squared plus 10 squared is going to give us this side squared. But we just want the distance of this side. So we'll have to take the square root of that. And now we know the length of this new road in terms of x, which is going to be the difference between x is going to be the amount of the abandoned road before we get to that shortest point to Foxton that we're not using, that we're not going to pave. So we are going to have, when we pave this, we know that we've got $6.8 million budgeted for this project. So for every part of the abandoned road, so let's consider how much we have. All the way to here is 40. But if we take off this x, the amount of the abandoned road that we're going to be paving is going to be 40 minus x is how much we're going to be paving of this abandoned road. And so 40 minus x times $100,000 is part of our cost. And the other cost is this new piece of road. So we're going to add to that 200,000 times this distance. So we've got the square root of x squared plus 10 squared. So let's just, we'll write it as 10 squared on this first line, is equal to, we're going to spend no more than, we're allowed to go up to $6.8 million. Oops, I'm sorry, forgot to put this amount times the 200,000, because that's how much it cost us for every mile over here of new road, is going to be our 6.8 million, otherwise known as 6,800,000. Okay, so now we've got a problem, an equation that we can use to solve for x. It's not pretty because we've got the square root and we've got all these 100,000s. Honestly, we could simplify it a little bit if we divide both sides of the equation, or every part of the equation, by 100,000, because that'll help get rid of some of these zeros and make it a little bit easier to work. So I'm going to take this. Now usually we do not want to divide until we're on the last step, but because I've got all these zeros floating around and I'd rather not have to keep writing 0 over and over again, I'm going to go ahead and do this now, just so I can make the numbers smaller and easier to work with. So I hope you see that this 100,000 cancels with that 100,000. That leaves us 40 minus x right here. Plus we've got 100,000 cancels with that, leaving 2. So it's 2 times the square root of x squared plus, and let's go ahead and take that 10 squared and call it 100. is equal to, let me move that up, make sure you can see it, is equal to, so when those cancel, we mark out 5 zeros in each place, and it's equal to 68. So we're trying to get x all by itself, trying to solve for x. Let's subtract 40 from both sides. And so we're going to get negative x plus 2 square root x squared plus 100 is equal to 28. Now we could add x to both sides. So what I'm trying to do at this point is isolate that square root part so that I can square both sides. So this will cancel. That'll leave me 2 square root x squared plus 100 is equal to 28 plus x. Now if I square both sides, I can get rid of my square root, and that will help me out. So let's do that. When I square this side, I'm going to square the 2, that'll give me 4, and then when I square this part, so let me write that down, I'm taking x squared plus 100, I'm taking the square root of that, and I'm squaring it, because I've already squared the 2 part. And that's going to be equal to, when I square this, so 28 getting squared is going to give me 784. 28 times x, for the middle term I get 28 times x, which is 28x, and I double that, so I get 56x. And then I square the last term, so that's plus x squared. So now, when I square this inside part, I hope you remember that it brings out what was on the inside of the square root. So that'll be 4 times x squared plus 100. So that's equal to 784 plus 56x plus x squared. So let's multiply through now. Let's use distributive over here. 4x squared plus 400 is equal to 784 plus 56x plus x squared. So now we're getting closer. We've got a quadratic. If we just get everything on one side and set this thing equal to 0, we'll be able to at least use the quadratic formula, if not possibly factor this. So let's subtract x squared. We'll subtract 784 from both sides. We've got to subtract 56x from both sides. So I'm going to have to do that in the middle. I didn't have any x's over there. So 4x squared minus x squared, that's a 3x squared, minus 56x, and then here we've got minus 384 is equal to 0. So now we've got, excuse me, a quadratic, and it's equal to 0. We'll just go ahead and just use the quadratic formula for this. X is going to be equal to, so our A is going to be a 3, our B is going to be a negative 56, and our C is a negative 384. Alright, so we're going to plug that into negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is a negative 56 plus or minus the square root of negative 56 getting squared minus 4 times a, which is 3, extend that a little more, times c, which is negative 384, all over 2 times a, which is 3, and so we've got x is equal to 56 plus or minus, so when we square 56, I have to do that on my calculator because that doesn't roll through my head fast. We get 3136, and then minus 4 times 3, so that's minus 12 so far, times a negative. So negative times negative is positive, so 384, so that's going to give us plus 4608, all over 2 times 3 is 6. So we've got 56 plus or minus the square root, so 4608 plus that 3136 is going to give us 7,744 all over 6. So let's see if we can find a square root of that. So if we wanted the square root of our answer, we would get 88. How about that? There is a square root. So we get 56 plus or minus 88 over 6. Excuse me. And so there's going to be two answers that we're going to get. One of them is when we take, let me make sure you can see what I'm writing over here. I can put it cooperate, and you can. So one of them is what we get when we take 56 plus 88 and divide by 6. And so 56 plus 88 divided by 6 is going to give us 24. And the other one is what we get when we take 56 minus 88 and divide by 6. And we can see right away that that one's not going to make sense because we're going to get a negative distance, and we don't want to know how far on the other side of Grimley that it would be. And so this one doesn't even make sense to our problem. So we're after that 24 is the one that's going to make sense for us to use for x. So x is equal to 24 foot of roadway. And so, excuse me, now we need to, so what we just said was we want this amount to be 24 foot. And so how much of it, so let's see, use the figure to help set up a model to determine how much of the abandoned road should be used if 6.8 million is budgeted for the project. And so if this much of it is going to be 24, then the abandoned road that we're using is going to be 40 minus 24. So we're going to use 40 minus 24 miles, which is going to be 16 miles. And so we're going to be using 16 miles of the abandoned road and repaving that, and then much of it, repaving 16 miles, and then taking off from there to do this amount up here, the, what would it be, 24 squared plus 100, and take the square root of that. Okay, so now the question becomes, the next question that our problem asks, so then that one was 16 miles of abandoned road. Our next question asks would it cost less than this amount to build a new road connecting the towns directly? So let's go back to our figure. So to connect these two towns directly, now our right triangle is going to have 10 over here, and it's going to have 48 over here. So this distance is going to be the square root of 40 squared plus 10 squared. And so let's see how much that would cost us to pave. It would be all new road, and so we've got the square root of 40 squared plus 10 squared is going to give us the square root of 1600 plus 100, so that's the square root of 17 hundredths. So that's going to give us 10 times the square root of 17 is what that's going to cost, which works out to be approximately 41.231. And so over here, it's all brand new road, so we're going to be multiplying that 41.23 miles, 0.231 times 200,000 per mile. And so that would end up costing us about $8,246,211.25 approximately, which is more than the $6,800,000 that we said. And so really, I don't know why I boxed that. That is not my answer. That is how I figured out my answer. The answer is no, it would not cost us less to just build a road directly between the two towns. We're better off using part of that used abandoned road that we've got.